Okay, so now we get to do least common denominator. If we remember in fractions, because that's what kind of what we've been doing in this chapter is fractions. Least common denominator is always found before we add or subtract fractions. So we have a goal here in mind. We have to know what to do to our bottoms in order to what to do to our tops so we can rebuild that fraction. First thing is we have to find that common denominator. So when we're talking least common denominator, all we're doing is looking at those things in the bottom or the denominator. So let's go ahead, get my pen over here somewhere, and let's just take a look at a very simple problem, right? 7 over 15 and 21 over 20. Now, if you have that least common denominator, or least common multiple found in my denominator, that's great if we can identify it. Yes, you can go multiples of 15, 15 times 1, 15 times 2, times 3, so on and so forth, 20 times 1, 20 times 2, 20 times 3, so on and so forth. And here again, we're looking for 15 times 4, which is 60, to where these two guys are the same. Now, if you remember in class, I showed you how to do this, but I didn't do it this way because I knew that eventually one day we would be here. Okay? What I taught you how to do was 15. Two factors are 3 and 5. So I write them down into prime bases. 20 goes to 4 and 5, which is 2 and 2 again, which is 2 squared times 5. And then I list my bases. If you remember this, I have a 2, a 3, and a 5. Highest exponent of each. So I have a 2, highest exponent is 2. I have a 3, highest exponent is 1. And I have a 5. Doesn't matter how many 5s I have. Their highest exponent, though, is still 1. So 4 times 15 is still 60. And the reason I showed you this guy, right, this guy, is because eventually we would be using it again. And this is the way our letters work as well. So versus memorizing numbers versus letters, we have a way of doing them both. So let's take a look at another problem or so. And let's just do letters here. So I have a 3 over n, and I have a 7 over n. And let's make this n cubed. All right. So my least common denominator, I list my bases, base n, highest exponent of each. I have 3 of them. Notice how much easier my letters work than my numbers do. Let's do one with numbers and letters, maybe. So let's look at 13. And we're going to go 5a squared b cubed. And then let's look at, who cares, 29. 15a to the 5th b. So my least common multiple of my denominators, or least common denominator, between 5 and 15, well, 15 is a multiple of 5 actually, so that makes that one real easy. I have an a and I have a b. Highest exponent of a's is 5. Highest exponent of b's is 3. Least common denominator. Sweet and simple. This next one I want to show you has got kind of a twist to it. 3, and let's go a minus 8, and let's go negative 17, 8 minus a. Now if you see these guys are exactly the same but opposites really. They're in different order. Positive a, well here I have a negative a, and we've done one just like this. So I'm going to extract that guy real quick. I'm going to put it in the order that I wanted in, which is negative a plus 8. Okay, and I'm doing this guy because typically my letters go first, my numbers fall behind. I'm going to take this guy, I'm going to factor out that negative 1, and I get an a minus 8. And now I'm going to manipulate the hell out of it. I'm going to take this negative 1, and a negative over a negative is a positive, so I'm just going to slide that guy up there, right, up top. And now what that gets me is a positive 17 over a minus 8. So my least common denominator is actually a minus 8. Now, warn you, there are different answers to this problem. Okay, if I would have switched this guy to that, then I'd have ended up with the negative 3 up here and the 8 minus a over here. Or I could have used the negative 1 in everything and had a negative 1 and this 8 minus a. Excuse me, a minus 8 sitting here. So there's different looks to this answer depending on where you did what your work and how you did it. This is why I chose this way, simply because we're going to see this happen again, and this is the one that typically works out the easiest. All right, so kind of pay heed to that. Now, 4x squared, x minus 4 quantity squared. Let's go 17. Let's go 3x minus 12. All right, as you can see, my denominator, this guy's factored. Please don't foil that back together. It's factored, it's prime. This guy is not, okay? So if I factor this guy, 3 comes out, I get left with x minus 4. Now, here's I'm going to get to the answer, and then we're going to talk about it. Highest exponent of 2, because of that guy. This is what the result is when you factor a perfect square trinomial. And this is exactly why I want a perfect square trinomial factored with a 2. Had I expanded this to x minus 4, very easily could have put just 1 up here as its exponent. That's not what I'm looking for. Highest exponent of each. Remember, this is my denominator. Once I label it, I have grouped it. This is one thing, highest exponent of 2. Be very, very careful of that. That will catch you as well. Let's do one more problem before we leave. I got a board here that I'm cheating off of, so I'll flip my board because I'm writing sideways. This is -5. I'm going to come out here to k squared plus 2k minus 35. I also have 19. I have k squared minus 2k minus 15. And these guys factor in, it's great. This 1's the coefficient here. So I can actually go right to my factors. I have a 7 and a 5 to get 2. K and k to get k squared. I have to have a positive 2, so my larger sign is positive. My larger number is positive. 2 factors here of 5 and 3. Still have the k up front. Have to be opposite signs. A negative here and a positive there. So my least common multiple found in my denominator. I have a k minus 5. I have a k plus 7. I have a k plus 3. And yes, I have this k minus 5 again, but that just means highest exponent of each. They're all just 1s. So this is actually my answer here. And yes, I could have had squareds, cubes, could have had every one of these terms listed. They may not have been the same. I just list my terms, highest exponent of each, and very simply it comes out to my least common denominator. Next lesson, we're going to learn how to find a least common denominator, rewrite fractions as equivalent so we can add or subtract.